Hello everyone, welcome to this part of the video where we are given that Mercury is a closest planet to the Sun, and we are given the distance. Okay, the distance is here in meter, and we are also given 1 megameter is 10 power 6 meter. Convert the distance in megameter. That means how many megameters do we want? And for part A, therefore, the required distance, which is the conversion, would then be equals to, I just need this, 4246 times 10 power 10, right? I just need to divide by 10 power 6 so that I will know how many megameters that will be. And this will give me a value of 54246 megameters. Okay. Part B. Similar question. We are given the wavelength in meter, and they introduce 1 nanometer is 10 negative 9 meter. How many nanometer would this be? So the required wavelength would then be equals to just this 3.8 times 10 power negative 7. I just need to divide by 10 negative 9, and this will give me the required wavelength in nanometers, 380 nanometers. Let's move on to the next question. Hello everyone, welcome to this question where we are given this table where we have the mass of a carbon atom and an oxygen atom. And they do let us know that the carbon dioxide has 1 carbon atom, carbon is this, and 2 oxygen atom. Find the mass of a carbon dioxide. So this is pretty straightforward. So the mass of carbon dioxide, CO2, will then be pretty straightforward. It is equal to 1 carbon atom, which is 1.99 times 10 to the power of negative 23. I just need to add 2 oxygen atom. So 2 times 6, 2.66 times 10 power negative 23. Okay, and this will give me the answer of 7.31 times 10 to the power of negative 23 gram. Part B. We have n number of molecules, some number of molecules, and the total mass is given. Oh, that's good. So how do I find the number of molecules? Yep, very good. I already got the mass of 1 carbon dioxide, you see. So n will therefore equals to, the number of molecules will therefore equals to the total mass divided by the mass of 1, which we have successfully found in part A. And this gives me a value of 6 times 10 to the power of 15, which is already in standard form. With that, we have come to the end of this question. If you like this video, do give it a thumbs up. Thank you for watching, and have a nice day as I explore the next problem. Hello everyone, welcome to this problem where we are given that Apollo 1, oops, okay, make it bigger, yeah, Apollo 1 or 11 becomes the first space flight to bring 2 humans, and on that flight, right, the computer that they have this value bits of the memory. And today, we have most smartphones have this amount of bits of memory. So what is the percentage more for the smartphones than on the Apollo 11? So the required percentage will be equals to, first we must know the difference, right? And so we will need to first find the difference between the two. So it's 4.096 times 10 power 12 minus away the Apollo 11 memory over the original memory, because we are talking about percent, so times 100%. All right, and this will give me a value of 694444344.4. Final answer to leave in 3 sig fig. And better still, if we could leave our answer in standard form, we will do that. Okay, so I will have 1, 2, 3, 4, 5, 6, 7, 8 times. So 6.944443444 times 10 power 8. And to leave final answer in 3 sig fig, 6.9 I look at this, so this is less than 5. 6.94 times 10 to the power of 8 in 3SF. With that, we have come to the end of this problem. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day.